Hello everyone, welcome to this video. In this video, we'll be talking about the next example which do not provide us with isomorphism. For that, we are considering the multiplicative group modulo 10. So it would contain all the numbers which are relatively prime to the number 10. So we have the number 1, we have the number 2 would not come because the GCD of 2 with 10 is 2 and not 1. Next 3 would come, 4 would not come because its GCD with 10 is 2 and not 1. So they are not relatively prime. Similarly 5 would not come, 6 would not come, 7 would come, 8 would not come, 9 would come. So these would be the elements. And then we are taking the multiplicative group modulo 12. So we are considering all the numbers which are relatively prime to the number 12 here. So therefore we can take the number 1, we can take the number 5, we can take the number 7, we can take the number 11, right? So now we are saying this U10, this is not isomorphic to U12, right? So you might be thinking why this is so, because here also we have 4 elements, here also we have 4 elements, so they could be isomorphic to each other, but they are not. So let's see why this is so. So we'll be proving this thing through the way of contradiction again. So what we do is we suppose that U10 that is isomorphic to U12. If that is so, so that means we have the mapping. Let's suppose the mapping is 5. So we suppose that this mapping 5 forms an isomorphism. So that means this would be 1 1, this would be on 2, and this would also be operation preserving in nature. So this is these are all our assumptions here, right? So what we do here, suppose we take 5 of some element 9. So 9 is the element of U10. We apply 5 onto it. Now let's see what do we obtain here. So when we apply 5 onto 9, you can write 9 as 3 multiplied by 3, no issue. Now because we have order operation preserving property, so 5 of 3 into 3 could be written as 5 of 3 multiplied with 5 of 3 according to operation preserving property. So this could be written as 5 of 3 whole square. Now this thing is equal to 1. Why? Because in U12 we have this equation true for all the elements. That means if you have the square of some number, so it is always equal to 1. So let's verify this thing first. We have all the elements of U12 here, which are 1, 5, 7 and 11. So let's check them for it. So when we take the square of 1, right, we are verifying this equation. So when we take the square of 1 for the elements x is equal to 1, 5, 7 and 11, right? So when we take x as 1, its square is 1 only, and when we take 1 mod 12, because we are in U12, so it means we are having 1 as the remainder, because when you divide 1 by the number 12, you would have 1 as the remainder. Next you have 5 square, which is 25. When you divide 25 by 12, you would have 1 as the remainder, right? So this is also true. Then 7 square is 49. So when you divide 49 by 12, you would have 1 as the remainder, and so this is also correct. And what about 11? 11 square is 121. So when you divide 121 with 12, you would have 1 as the remainder. So therefore this is also correct. So therefore when we have the square of any number in U12, it is always equal to 1. So this is first equation. Similarly, let's check for phi of 1. For phi of 1, again you can write 1 as 1 multiplied by 1. Again by the operation preserving property, we can write phi of a into b as phi of a into phi of b, right? Again we can express it like this, phi of 1 whole square, and again because of this equation here, x square is equal to 1, this term is equal to 1. So you see the answer to both of these equations, they are 1. So that means phi of 9 is equal to phi of 1, but actually 9 is not equal to 1 in the group U10. 1 and 9, they are different to each other. So therefore phi of 9 is equal to phi of 1, but 9 is not equal to 1. So this contradicts the assumption that phi is 1 1, right? Because we have assumed that both the groups, they are isomorphic to each other, so that means the mapping has to be 1 1. But here we have proved that this mapping is not 1 1. If it is not 1 1, so that means it cannot be isomorphism. So this is what we wanted to show here and give you an example of the groups which are not isomorphic to each other. So I hope you understood these examples well. Well, that is it for this video. Thank you for watching.